So now that we've seen how to graphically represent the budget constraint and what happens when there's a change in the budget or a change in one of the prices, we can think of how we can graphically represent preferences. So how much utility people get from different goods. So let's turn our attention now to preferences. And so, at the beginning of this module, what we had to do to represent preferences is kind of give a list of all the different amounts of margin utility that someone got from from consumption of different amounts of units of these of the goods that we were looking at. So before, we needed to list all the, I'm going to say MU for marginal utility amounts that a consumer got from consumption of a certain amount of a good. It's a pretty long, convoluted sentence, but basically before we had to list all the different margin utilities associated with all the different quantities, right? And we talked about that there was diminishing marginal utility, so the more we had, the more we consumed or more we purchased of something, the marginal utility of that consumption would go down. But we kind of basically had to list all the marginal utilities we got from consuming the first good and then the second and the third. That's kind of what I'm saying here. Now we're going to use something called indifference curves. Now we will use indifference curves. And so what these indifference curves are is that they're going to be a graphical representation of different bundles of goods that a consumer is indifferent towards, in that it gives them the same total utility. So let's just put a graphical representation. I mean, it's a function that represents different combinations of goods that give someone the same amount of total utility. Of different consumption bundles. So remember, consumption bundles are different combinations of these two goods that we're looking at. A graphical representation of different consumption bundles that give us the same total utility, or the consumer the same total utility. So let's hopefully we'll be able to see it like a small graphical representation of what that looks like down here. All right, so again, let's put mangoes and fish on the two axes. Let's just continue that example. And so what an indifference curve is, let's say something looks like this, and we're going to label it, let's say I1 for an indifference curve 1. And so what this is saying is that any combination of goods along this line give this person, this consumer, the same total utility. So they're called indifference curves because consumers are indifferent between consuming any different combination along this line. So for example, let's think about point A. Well, point A is a consumption bundle, a particular consumption bundle with, let's say, quantity of fish A and quantity of mangoes A here. So QM, I should have the same superscripts and subscripts here. Quantity of mangoes for point A. And what this is saying is that this consumer is indifferent between having this many mangoes and this many fish, or something like this, where we have significantly less fish, so QF, let's label this B. So this consumer is indifferent between these two amounts of mangoes and fish, or these amounts of mangoes and fish. So having a lot less fish, but more mangoes. And so any point, and that's going to be true for any kind of different, you could have another point C here if you want, different amount, but any different combination of consumption or combination of goods or different consumption bundles along this line, the consumer is indifferent towards purchasing and consuming. All right, so before we kind of get to the maximization part of it, let's talk about a few different properties of these indifference curves. In particular, we're going to talk about 4 different properties of these indifference curves.